I'm going to try and stay with the screen recordings here because the other ones kind of take a long time to upload. I've discovered that to upload them on YouTube by using the Kaltura thing on because one I make this the we have students that are in case we have students that are hearing impaired or visually impaired. I'm trying to make this class more accessible because we advertise that this class is accessible to everyone, and so we got to make it accessible, and that helps because YouTube, unlike Kaltura, YouTube will do closed captioning for us. So that's a nice feature. Anyway, I don't know why I always have to tell you my business. I just kind of feel like I do. All right. Anyway, we're going to be talking about pressure. The first thing I want you all to do, right now, while I get this loaded, is look at your thumbnail. All right, we're going to look at the pressure of fluids, materials that flow, and we're going to look at how things react in water and in air. Okay, and first thing we're going to talk about is pressure. This is literally a lump of coal that has been turned into a diamond in our lab, in Dr. Kruger's lab, and it's a nice picture that he took. We have been processing diamonds. People have been in high-tech labs for a long time because they're used in drilling and just fracking around. All right, those kinds of things. Because if you went to DeBerg's to buy your diamonds, or waited for the horrible conditions of the South African mines to come to fruition, you wouldn't have enough drill bits to go get all the oil we need. So anyway, let's talk about pressure. Looking at your thumbnail, how many pounds per square inch? How many pounds per square inch are smashing down on your thumbnail right now? Take a wild guess. We'll get to that in a minute. That's your cliffhanger. All right. So anyway, and that would be 1 atmosphere that's smashing down. So under pressure, these tennis balls feel 2 atmospheres of pressure. And so the pressure, when we talk about the pressure here on Earth, it's 1 atmosphere, but it gets less as you go up higher because the pressure of air, if an object's in a fluid, the fluid above will exert a weight or pressure on the object, and air has pressure. Okay, here's our guy standing here, and its pressure is equal to the density. That's what that little rho stands for. Remember the commercial where the guy was charging his computer with the little guinea pigs? He said rho, the guinea pig. Funny word, rho. Well, that's RHO, rho, right here. And times G, which we know is 9.8, times the height, how high it goes up. All right, so the density, rho is the density, and air is about 1.2 kilograms per meters cubed. So if you look at the desk that you're sitting at, it's about probably close to a meter high, a meter wide, probably half a meter deep. If you put 2 of your desks together, or just look at a regular table in the library, so that's about 1 cubic meter. So air actually has a mass of 1.2 kilograms. Multiply that by 9.8. You roughly have a weight of about 11 newtons, okay, or about a half a pound. So there's some weight, and if you get enough of it, if a tunnel that's high, notice it has nothing to do with going crossways. It's all about going how high you can go, all right? And so you get this thing times 10,000 meters. That's about 117,000 pascals, PA. That's what we use in our. That's funny. I didn't know I could do that. Got way ahead of myself. All right. This is close to about 14.7 pounds per square inch. There, we got to it. All right. It's about 15 pounds per square inch is smashing down on your thumbnail right now. That's like a large bowling ball, or even bigger than that's like 2 bowling balls smashing down all over your body. That little, just that one. If you took that 1 square inch, put it all over your body, but 15 pounds, you're getting smooshed, but you're so used to it, you don't realize it. In fact, we've adapted. That's how we live here on Earth. So if you go to the moon where there's no atmosphere whatsoever, guess what? Bad things happen. Do you explode? Not really, but your blood starts to boil. It gets bad. if you don't have, if there's no atmosphere, things get bad really quick. All right. Or one atmosphere, 760 millimeters of mercury, or 29.9 inches. They're always saying on the weather, the mercury. They used to say the mercury because farmers paid attention to that. And they knew if the mercury was falling, we got less pressure moving in. A low pressure means there's weather coming in, bad weather, possibly storms, or good old rain. The farmers need, like today is a beautiful rainy day. All right, and we can use this to make extreme pressure cannons. All right. Basically, this is from our lab. This is a demo that I use quite a bit. It's our air pressure cannon, and it is a lot of fun because we can shoot a ping pong ball right through that empty can of Coke. All right, so let me record this section, then I'll show you some air pressure things that work here, videos. I gotta find it first. There we go.